This is section 3.6 on rational functions. Get you the homework for that. Okay, so 3.6 begins on page 344. We have to do 13 through 67. So here we are. Some more. So rational function has fractions. It's a polynomial divided by another polynomial. Perhaps. And there we go. And we had to go up to what problem? 7 there. Okay. Okay, problem 15. S of x is 3 over x plus 1. So we start with our basic function 1 over x. So you should be familiar with 1 over x looking like this. 3 over x, you multiply by 3, you stretch the graph by a factor of 3. So 3 over x, and then 3 over x plus 1 moves the whole graph 1 unit to the left. So it ends up looking like so. Okay, so x equals -1 is a vertical asymptote. The domain is all real numbers minus a set consisting of -1. The range is all real numbers minus a set consisting of 0. 17, there's a trick that you do. 2x minus 3 can be written as 2x minus 4 plus 1. The reason why you want to do that is because this turns out to be 2. 2 plus 1 over x minus 2. Okay, so starting with 1 over x. 1 over x minus 2 moves the graph 2 units to the right. And then 2 plus 1 over x minus 2 takes the graph and moves up 2. So the red is the final answer of what I want. So domain is all real numbers except for 2. Range is all real numbers except for 2. Okay, 23. Factor the numerator into x minus 2, x plus 1 over x minus 6. So the intercepts are 2, 0. We can read 2 there. 2, 0, -1, 0, and 0, 1/3. Put 0, 0, minus 2, 0, minus 6. So -2 divided by -6 is 1/3. So those are my intercepts. Okay. And problem 29. Okay, so intercepts looks like 0, 0.25 roughly. And plus or minus 1, 0. Right over here and right over here. Okay, horizontal asymptote looks like y equals 1. Vertical asymptote, x equals plus or minus 2. So horizontal asymptote, y equals -1. Vertical asymptote, x equals -2, and x equals 2. Okay, 33. R of x is 3x plus 1 over 4x squared plus 1. The denominator can never be 0, so there's no vertical asymptote. Horizontal asymptote, this is first degree divided by second degree. The second degree is going to win in the long run, so in the long run, the ratio is 0. So y equals 0 is a horizontal asymptote. 37, if you multiply this out, you have 2x squared plus blah, 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 4x squared plus blah, blah, blah. So you just take the ratio of the leading coefficients if these are the same degree, second degree. So horizontal asymptote is y equals 1/2. Vertical asymptote, what makes this 0? 2. What makes this 0? -7/4. So x equals 2 and x equals -7/4, or vertical asymptotes. Horizontal asymptote, we said, was y equals 1/2. Okay, 45. We have this, which cannot be factored. You try it, it doesn't work. Over x minus 2 squared. The top, if I tried the quadratic formula, b squared minus 4ac, b squared is 144 minus 4 times 3 times 13. That's less than 0. It cannot happen. So the numerator is either always positive or always negative. The easiest thing to do is plug in a number like 0, 13. Okay, it's positive. So this is always positive. But notice the denominator is always positive except for 0. So wherever this quantity is defined, it's a positive quantity. Okay, so horizontal asymptote. Okay, second degree, cover this up. The ratio is 3, so y equals 3 is your horizontal asymptote. If I go way out to the left or way out to the right, the graph gets close to y equals 3. And let's see, if I plug in 0, 0, 0, 0, 0, I get 13 over 4. So 0, 13 over 4. All right, so I have a vertical asymptote. We know the graph cannot be negative, so they both shoot up toward infinity, and they both go toward the horizontal asymptote of y equals 3. So the domain is all real numbers except for 2. Range looks like 3 to infinity. 53. Here's the original r of x. So my intercepts are 1, 0, negative 2, 0. What makes a fraction equal to 0? When the numerator is 0. And when you plug in 0, 0, 0, 0, I get negative 2 over negative 3, which is 2/3. If you multiply that out, it's x squared plus something divided by x squared plus something. So the ratio of the coefficients is 1. So horizontal asymptote, y equals 1. Vertical asymptote, x equals negative 1, x equals 3. So here we go, negative 1, 3. What do we say? 1, 0, negative 2, 0, 0, 2/3. Okay, then what happens near the asymptotes? So a little bit to the left, negative 1.01, negative, positive, negative, negative. 3 negatives makes a negative, shoots down to negative infinity. This side I already know goes toward y equals 1. Negative 0.99 is a positive, negative 0.99, negative, positive, positive, negative. 2 negatives make a positive. So on the right side of x equals negative 1, we shoot toward infinity. Touch here, touch here. How about over here? So 2.99, 3 positives and a negative, 2.99. Positive, 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 negative. Multiply them and divide them, you get a negative, shoots down to negative infinity. On this side, if I go way out here, we approach y equals 1. Over here, it looks like positive infinity. Plug in 3.1 or 3.01, either way. Positive, 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 they're all positive. So positive. So here's my graph. Looks like the range is all real numbers. Goes as high and as low as you want. Domain, all real numbers except for negative 1 and 3. Okay, 59. X squared minus 2x plus 1 factors in x plus minus 1 squared. X squared plus 2x plus 1, x plus 1 squared. This is not defined at negative 1. So vertical asymptote x equals negative 1. These are both second degree, so the ratio of the leading coefficients is 1. So y equals 1 is a ha, vertical horizontal asymptote, and the only va, vertical asymptote, is x equals negative 1. Okay, I notice that y is greater than or equal to 0 whenever this is defined. The graph is exactly 0 when x is 1, so it touches right there. Okay. And beyond that, well, you know it's not going to go down. This expression cannot be negative, so it goes there, up, up, and goes toward the asymptote right there. 63, if you factor, you get x plus 5, x minus 1 over x plus 2, x minus 1. These cancel out as long as x is not equal to 1. So at 1 comma, plug in 1, you get 6 over 3, which is 2. 1, 2 will be a hole. So I'll just go ahead and graph this, but there's a hole at 1 comma 2. Intercepts. Plug in 0, you get 5 over 2. Set the numerator equal to 0, x is negative 5. So negative 5, 0, 0 comma 5 halves. Take the leading coefficients. X divided by x is 1. So y equals 1 is a ha, horizontal asymptote. Go here, go here. Okay, let's get near the vertical asymptote. Negative 2.1. That's a negative divided by negative, which is positive. Sorry, positive divided by negative is negative, negative 2.1. Negative 1.9, positive, positive, shoot toward infinity. Okay, so this branch goes like that, but there's a hole at 1 comma 2. Okay, this one, if I do synthetic division, 1, -5, 3, 9, divided by x plus 1 means put -1 here. Okay, 1, multiply, add, multiply, add, multiply, add. So this is indeed a factor. And I'm left with x squared minus 6x plus 9, which I can write as x minus 3 quantity squared. Okay, so these are identical except at -1. -1 comma 16 I have a whole. Other than that, it's a parabola. Y equals x cubed. Move 3 units to the right. So there it is. And there's a whole at -1 comma 16. All right, so this is section 3.6 on rational functions.